Hello everyone. In this lesson I'll complete solving the exercises of lesson 3.2. We reach number 36. Find the derivative of this function. The derivative of this function is f prime of x equal to, derive the bracket first, to x plus 5 over x squared plus 2. Then multiply by the derivative of the inside of the bracket, the denominator x power 2 plus 2 times the derivative of the numerator 1 minus the numerator x plus 5 times the derivative of the denominator 2x over the denominator square. Then simplify this derivative f prime of x equal to 2x plus 5 over x power 2 plus 2 times x power 2 plus 2 minus 2x power 2 minus 10x over x power 2 plus 2 all power 2 equal to 2x plus 5 over x power 2 plus 2 times x power 2 minus 2x power 2 minus x power 2 minus 10x plus 2 over x power 2 plus 2 square equal to x power 2 plus 2 cube 2x plus 5 times negative 2x square minus 10x plus 2. Question number 37. Find the derivative of this function. F prime of x equal to derivative of division of two function, the denominator times the derivative of the numerator 6x minus the numerator times the derivative of the denominator 2 over denominator square. Simplify this function. 6x times 2x, 12x squared, 6x times 3, 18x, 2 times 3x squared minus 6x squared, 2 times negative 2, negative 4 times negative positive 4 over 2x plus 3 squared equal to 2x plus 3 in the denominator square, 12x power 2 minus 6x power 2, 6x power 2 plus 18x plus 4. Question number 38. The derivative of this function is, apply the rule of derivative of division of two functions. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator 4x power 3 over 2 square root x power 4 plus 1 over x power 4 plus 1 square root of x power 4 plus 1 square, it is x power 4 plus 1. Simplify this function f prime of x equal to square root x power 4 plus 1 minus 4x power 4 x times 4x power 3 4x power 4 over 2 square root x power 4 plus 1 over x power 4 plus 1 equal to the common denominator for the two fractions in the numerator 2x power 4 plus 1 2x power 4 plus 1 times x times square root x power 4 plus 1 it is 2 x power 4 plus 1 minus 4 x power 4 over x power 4 plus 1 equal to multiply 2x power square root x power 4 plus 1 with x power 4 plus 1 it is 2 x power 4 plus 1 to the 3 over 2 in the numerator 2x power 4 plus 2 minus 4x power 4 equal to 2x power 4 minus 4x power 4 minus 2x power 4 factorized by 2 then the final answer will be 1 minus x power 4 over x power 4 plus 1 to the 3 over 2. Question number 39. Derivative of ln x power 2. It is f prime of x equal to x power 2 in the denominator and the derivative of the x power 2 in the numerator. Reduce x with x power 2. The final answer is 2 over x. Number 40, apply derivative of multiplication of two functions x and ln x. Then f prime of x will be x times 1 over x plus ln x 1 times ln x equal to reduce x with x 1 plus ln x. Question number 41. F prime of x equal to, since we have ln, then in the denominator we set x square root x power 2 plus minus 1, and in the numerator the derivative of the denominator. Apply the derivative of multiply of two functions x times 1 or 2x over 2 square root x power 2 minus 1 plus square root x power 2 minus 1 times 1. Simplify. F prime of x equal to x times square root x power 2 minus 1 in the denominator, x times 2x, 2x power 2 over reduce 2 with 2, then it will be x power 2 over square root x power 2 minus 1 plus square root x power 2 minus 1 equal to x square root x power 2 minus 1 common denominator for the two fractions in the numerator x power 2 minus 1, then x power 2 plus square root times square root, it is x power 2 minus 1 equal to x power 2 plus x power 2 to x power 2 minus 1, multiply the root with the root, then x times x power 2 minus 1 equal to 2x power 2 minus 1 over x power 3 minus x. Question number 42, f prime of x equal to, apply derivative of division of two function, x times derivative of the numerator 1 over x minus the numerator ln x times the derivative of the denominator 1 over x squared equal to x times 1 over x 1 minus ln x over x power 2. Question number 43. Apply the rule of ln 1 over x squared equal to ln 1 minus ln x squared equal to ln 1 is 0 minus ln x power 2. Then the derivative f prime of x equal to x power 2 in the denominator, negative 2x in the numerator, reduce x with x power 2, then the final answer is negative 2 over x. Question number 44, ln square root 2 plus cosine square x, f prime of x equal to fraction square root 2 plus cosine square x in the denominator and the derivative of it in the numerator. Find the derivative of the denominator here, then we rewrite it in the numerator. 2 plus cosine square x to the 1/2. Its derivative is 1/2. 2 plus cosine square x to the negative 1/2 times 2 cosine x times negative sine x. Simplify this derivative, reduce 2 with 2, move this root to the denominator, it will be 2 plus cosine square x in the numerator, negative sine x cosine x. Rewrite it here, negative sine x times cosine x over square root 2 plus cosine square x equal to negative sine x cosine x over 2 plus cosine square x. Number 45, the derivative of e to the negative x power 2 is f prime of x equal to negative 2x e to the negative x squared. Question number 46, f of x equal x power 2 e to the negative x, apply rule of multiplication of two functions, f prime of x equal to the first function x power 2 times the derivative of the second function negative e to the negative x plus the second function times the derivative of the first function. The derivative of the first function is 2x times e to the negative x. Simplify this derivative, negative x power 2 e to the negative x plus 2x e to the negative x. Question number 47, f of x equal to ln 1 plus e to the x over 1 minus e to the x. Rewrite this function as f of x equal ln 1 plus e to the x minus ln 1 minus e to the x. Then find the derivative of this, f prime of x equal to 1 plus e to the x in the denominator, its derivative in the numerator, e to the x minus 1 minus e to the x in the denominator and its derivative in the numerator. The derivative of negative e to the 1 minus e to the x, negative e to the x. Minus times minus plus. Then the common denominator e 1 plus e to the x times 1 minus e to the x, 1 minus e to the x times e to the x plus e to the x times 1 plus e to the x equal to, open the two brackets in the denominator, 1 times 1, 1, minus e to the x plus e to the x minus e to the 2x, e to the x times e to the x, e to the 2x. In the numerator, e to the x minus e to the 2x plus e to the x plus e to the 2x equal to e to the x minus e to the x. Then in the denominator will be 1 minus 2x, e to the 2x plus e to the minus e to the 2x plus e to the 2x 0, e to the x plus e to the x 2 e to the x. Question number 48, then e to the x, the derivative f prime of x equal to e to the x, derivative of t to the x in the numerator equal 1. Question number 49, apply derivative of division of two function f prime of x equal to the denominator e to the x plus e to the minus x times the derivative of the numerator 0 minus the numerator times the derivative of the denominator e to the x minus e to the minus x over e to the x plus e to the minus x square equal to 2 e to the x minus e to the minus x over e to the x plus e to the minus x square, negative 2 e to the x minus e to the minus x. Question number 50, f of x equal e to the x times bracket sine x plus cosine x. Rewrite this function as f of x equal to e to the x sine x plus e to the x cosine x. Now find the derivative f prime of x equal, apply multiplication of two functions for the first term, e to the x times the derivative of sine cosine x plus sine x times the derivative of e to the x, it is e to the x sine x, plus apply the derivative of multiplication of two functions for the second term, e to the x times negative sine x plus e to the x cosine x. Simplify, e to the x cosine x plus e to the x sine x minus e to the x sine x plus e to the x cosine x. E to the x sine x minus e to the x sine x, e to the x cosine x plus e to the x cosine x, it is 2 e to the x cosine x. Question number 51 and 52, find the equation of the tangent line to the graph of f at the given point. To find the equation of the tangent line, we need the slope and point. We have the point, and we find the slope from the derivative of this function. F prime of x equal to 4x cubed minus 6x. At the point of tangencity 1, 0, f prime of 1 equal to 4 times 1 cubed minus 6 times 1 equal to 4 minus 6 equal to negative 2. The slope is negative 2 and the point is 1, 0. Then the equation of the tangent line is y minus y1 equal to the slope negative 2x minus x1 equal to y equal to negative 2x plus 2. Question number 52. Find the derivative of this function to find the slope of the tangent line. Rewrite this function as f of x equal to 2 over x to the 3 over 4 equal to 2x to the negative 3 over 4. Then the derivative of this function is 2 times negative 3 over 4 x to the negative 3 over 4 minus 1 equal to, reduce 2 with 4, negative 3 over 2 x to the negative 7 over 4. At the given point, f prime of 1 equal to negative 3 over 2. Then the equation is y minus y1 equal to the slope negative 3 over 2 x minus x1. Then the equation is y equal to negative 3 over 2 x plus 3 over 2 plus 2 equal to negative 3 over 2x plus 7 over 2. Number 53 to 55, find the points, if any, where the tangent line to the graph of f is horizontal. The tangent line to the graph is horizontal when the derivative of the function is 0. Then we find the point, make the derivative of this function 0. F prime of x equal to 4x power 3 minus 16x. Set it equal 0 and find the value of x. Factorize by 4x, then x power 2 minus 4. 4x power 3 minus 16x. Either 4x equals 0, then x equals 0, the first point, or analyze a difference of 2 square, x minus 2, x plus 2 for the second term, then either x equal 2 or x equal negative 2. To find the y coordinate of this point, substitute this value in the function to find the value of y coordinate. 0 minus 0 plus 2, 2 to the 4, it is 16 minus 8 times 4 plus 2, 8 times 4, it is 32, 16 minus 32, negative 16 plus 2, negative 14. And for the last point, x equal negative 2, negative 2 power 4, 16 minus 8 times 4, negative 2 square plus 2, it is also negative 2, negative 14. Question number 54, find the derivative of this function f prime of x equal to, rewrite it as x to the negative 2, negative 2x to the negative 3 equal to negative 2 over x power 3, set it equals 0, cross multiplication, negative 2 equal 0, contradiction, there is no horizontal line to this function. F of x equal x plus sine x, the interval is between 0 and 2 pi. F prime of x equal to 1 plus cosine x. Set it equals 0, then cosine x equal negative 1, then x equal cosine inverse negative 1 equal to, in this interval, it is pi, because the graph of the cosine from 0 to 2 pi, it is like this. This is pi, and this is negative 1 and 1. So the value of x is pi. Substitute pi in the function. Pi plus sine pi is 0. It is pi. Therefore, the point is pi. Question number 56 and 57. Find the value of k such that the given line is tangent to the graph of f. At the point of tangency, the value of function equal to the value of the line, since the point of tangency belong to the graph and belong to the tangent line, and therefore x power 2 minus kx equal to 4x minus 9. Rewrite this function as x power 2 minus kx minus 4x plus 9 equals 0. This is the first equation. Also, the derivative of the function at the point of tangency equal to the slope of the line. Therefore, f prime of x equal to y prime. Therefore, 2x minus k equal to 4. Then, the value of k is 2x minus 4. Substitute the value of k in the first equation to find the value of x, then substitute in equation 2 to find the value of k. X power 2 minus 2x minus 4 times x minus 4x plus 9 equals 0. Then x power 2 minus 2x plus minus 2x square plus 4x square, plus 4x minus 4x plus 9 equals 0. 4x with 4x, x power 2 minus x 2x power 2, it is negative x power 2 plus 9 equals 0. Then x power 2 minus 9 equals 0. Then x equal to negative positive 3. This is the value of x. Substitute in Equation 2, to find the value of k equal to times 3 minus 4 equal to 6 minus 4 equal to 2, and k equal to 2 times negative 3 minus 4 equal to negative 10. Then this line is tangent to this graph in 2.2 and negative 10. Question number 57, the same steps of the previous question. K over x equal to negative 3 over 4 x plus 3 multiply by x, k equal to negative 3 over 4 x power 2 plus 3x multiply by 4k, or leave it as it. The derivative f prime of x equal to the slope of the line negative 3 over 4. Therefore, the derivative of this function, it is k times x to the negative 1 negative k x to the negative 2, it is negative k over x power 2. Therefore, negative k over x power 2 equal to negative 3 over 4. Cross multiplication, negative 4k equal to negative 3x power 2. Then k equal to 3 over 4x power 2. Substitute the value of k in first equation. Let me substitute here. Then 3 over 4x squared equal to negative 3 over 4x squared plus 3x multiply by 4, 3x power 2 equal to negative 3x power 2 plus 12x. Move all term to the one side. 3x power 2 plus 3x power 2 minus 12x equals 0. 6x power 2 minus 12x equals 0. Factorize by 6x, x minus 2 equal 0. Either x equals 0 or x equal 2. When x equals 0, then k equals 0. When x equals 2, then k equals 3. Since when x equals 0, k equals 0, but since x equals 0, it's not in the domain of the function of f of x. Therefore, k equals 0 is not the point of tangency of this line to this function. Therefore, the only point is when x equal 2, k equal 3. Question number 58 and 59, find the relation between the derivative of f and g. Find the derivative of this function, g prime of x equal to f prime of x plus 0. Therefore, the relation is g prime of x equal to f prime of x. For the question 59, find the derivative g prime of x equal to negative 5 f prime of x. Therefore, the relationship is g prime of x equal to negative 5 times f prime of x. Question number 60 and 61, identify the function f and its derivative from these two graphs. As you see, we have a line and a horizontal line. The horizontal line is for constant function, and this line is for a linear function with positive slope. When as you see, the line is increasing from negative infinity to positive infinity. Therefore, the function is positive. The derivative is positive, is over x-axis. Therefore, this is f prime and this is f. For question number 62, we have a quadratic function and a linear function. Of course, the linear function is the derivative of the quadratic function, and the function is increasing from negative infinity to 1. Therefore, the derivative is over x-axis from negative infinity to 1 and decreasing from 1 to positive infinity. Therefore, the derivative of the function is under x-axis from 1 to positive infinity. Question number 62 and 63 use this information to find f prime of x, where f of x equal to g of x plus h of x. F prime of x equal to 2g prime of x plus h prime of x. F prime of 2 equal to 2g prime of 2 plus h prime of 2 equal to 2. G prime of 2, it's negative 2, plus h prime of 2, it is 4. Therefore, the value is 0. Sorry, to find the f prime of 2. For question number 63, f prime of x, apply the derivative of multiplication of two functions, g of x times h prime of x plus h prime of x, h of x times g prime of x. Therefore, f prime of 2 equal to g of 2 times h prime of 2 plus h of 2 times g prime of 2 equal to g of 2, 3 times h prime of 2, 4 plus h of 2, negative 1 times g prime of 2, negative 2 equal to 12 plus 2 equal to 40. Question number 64 to 69, true or false? If f of x, f prime of x equal to g prime of x, then f of x equal to g of x. This statement is false since if we set f of x equal to x power 2 plus 1 and g of x equal to x power 2, then f of x not equal to g of x, but f prime of x equal to x and equal to 2g prime of x. Question number 65. If f of x equal to g of x plus c, then f prime of x equal to g prime of x. This statement is true. If y equal pi square, then dy over dx equal to pi. False, since pi square is constant and the derivative of any constant is 0. if y equal x over pi, then dy over dx equal 1 over pi. This statement is true since the derivative of 1 over pi x is 1 over pi. If g of x equals 3f of x, then g prime of x equals 3f prime of x. This statement is true. If f of x equals 1 over x to the n, then f prime of x equal to negative n over x to the n plus 1. Also, this statement is true because if we set the function as x to the negative n, then its derivative is negative n x to the negative n minus 1 equal to negative n over x to the n plus 1. Question number 70. Let f of x equal ax power 3 plus bx squared plus cx plus d. Find conditions for a, b, c, d so that f has no horizontal tangent line. We talk here about the tangent line, horizontal tangent line. Then the horizontal tangent line is when f prime of x is 0. Therefore, f prime of x is 3ax power 2 plus 2bx plus c. And this function, or this quadratic function, has no horizontal tangent line when b squared minus 4ac less than 0. If we set this is a and 2b is b and c is c, where a is coefficient of x squared, b is coefficient of x, and c is the constant. F has a unique horizontal tangent line. Unique root for this function is when b squared minus 4ac equals 0. F has two horizontal tangent line is when b squared minus 4ac greater than 0. Give an example for each function. For the first case, f of x equal 2x power 3 plus x plus 1. If we find the derivative of this function, it is 6x power 2 plus 1. Here the value of a is 6, the value of b is 0, the value of c is 1. And if we check b squared, 0 squared, minus 4 times a times c, we see that it is negative 24 less than 0. For the second case, the derivative is 3x power 2 plus 12x plus 12. And if we check this equation, b squared, 12 squared, 144 minus 4 times a, 3 times 12. 12 times 12, 144. Therefore, the answer is 0. For the last case, if we find the derivative, 6x power 2 minus 6x. And if we check this inequality, b squared, 36 minus 4 times a times c, 0, equal to 36 greater than 0. See you next lesson.